So, good morning and welcome back. So, today we're going to have your gene and genotypic frequencies. How are we going to compute for it? The gene frequency is the frequency of a certain trait, let's say gene, let's say black, present in a certain population. While genotypic frequency is the frequency or the number of animals that appear to have the gene or the trait. So let's say black, rowan, white. How many, let's say cattle in a herd of 500, how many of them happen to be black? How many of them happen to be rowan? It's a mixture of white and black. Or how many of them happen to be white? So we have here a problem. So a population of 100 Andalusian chickens. And I need my código. And then we have 36 of them. Of the 100, 36 happen to be black. 44 happen to be blue. So for blue, they're considered heterozygous. And 20 are white. So this is an example on your notes. So we're going to solve first the genotypic frequency. So when we say genotypic frequency, it's often being represented by capital letters, starting with the letter P. Capital letter P is the dominant trait. So when we say dominant, so meaning this one. So we have the dominant over total number of population. For H, this is the heterozygous. So we have the heterozygous dominant over total number of population. While the Q, we have the recessive and then total number of population. Since black is a dominant color for the Andalusian chickens, this is a breed of chickens, by the way. So we have 36. So 36 individuals happen to be black over 100. So we have 0.36. How about the heterozygous? So the heterozygote individuals, we have 44 out of the 100. So we have 0.44. How about the recessive? So there are around 20 individuals who happen to have the recessive trait, happen to be white. So we have 20 out of 100. So that's 0.20. To check your answers, you should have, I will adjust this, P plus H plus Q should be equal to 1. So we have 1. So P is 0.36 plus 0.44 plus 0.2. So 0.36 plus 0.44, that's 0.8 plus 0.2. So 1:1, and that is correct. So on your exam or on your quiz, make sure you check on your answers. I will pause for a while, and after this, you will pause for a while. And after this, I'm going to erase this, and we're going to solve for the genotypic frequency. So we're going to solve the genotypic frequency, or the gene frequency rather. So we have solved the genotypic frequency a while ago, and then we're going to solve the gene frequency. So instead of having the capital P, H, and Q, for gene frequency, it's small letters. So we have letter P and letter Q. So on your, so we have here, so with letter P, because letter P represents the dominant trait or the dominant gene, so you will be counting how many genes are there that happen to be dominant. So you have here 36 times 2 plus 44, and then over 200. Doc, you might be asking, Doc, why 200 when a while ago there was, when we solved for the genotypic frequency, it was over 100. There may be 100 individuals, however, per individual carries 2 sets of genes. Thus, it becomes 200. Because this time around, we will be counting on how many individuals possess this gene, and this gene, and this gene. The dominant and the recessive traits. Doc, why is it that 36 will have to be multiplied by 2? Because again, there are 36 individuals that carry the black genes, and these 36 individuals are homozygous black. Thus, both the capital letter B or the black genes are present. Thus, they have to be multiplied by 2. Doc, where do you get the 44? The 44 comes from the heterozygous individuals, the 44 blue Andalusian chickens. Because this 44 Andalusian, blue Andalusian chickens also possess the black gene. Thus, 44. Now we're going to solve this one. So use the MDAS rule. So you have to multiply first. So you have 36 times 2, that's 72, plus 44 over 200. So that's around 116, and that is 0.58. How about the letter Q? Letter Q, or small letter q, represents the recessive trait or the white gene. So we have here 44. Again, 44 came from here because these 44 individuals also have the white gene, being a heterozygous. Time 2, and then 20. Again, the reason why we have to multiply 20 by 2, because the 20 individuals that happen to be white also possess the recessive genes of being white. Over 200. 44. So 44 plus, that's around 40, right? For 200. So 44 plus 84 out of 200. So Q is 0.42. Now, again, similar to the gene frequency, you also have to do a rechecking. The genotypic frequency and the gene frequency should always be equal to 1. P plus Q is equals to 1. So 0.58, 42, and that is correct. You really have to do your rechecking just to check if your answers are correct. There are questions regarding how you do this. You have to do this step by step. If you miss one, you are wrong already. In the next video, I'm going to share to you how to compute for the Hardy-Weinberg equilibrium. Until then, I'll see you later and take care.